10.6 Circles and Arcs. The objective in this lesson is to find the measures of central angles and arcs, and also to find the circumference and arc length. So quite a bit of vocabulary here at the beginning. A circle is the set of all points that are equidistant from a given point called the center. So we have the center right here, and the circle is just the line that is all points as you take the radius and just go around. If you can imagine like a piece of string or a compass, and we just go all the way around the center, and that's what the circle is. It's all points equidistant from the center. We name a circle by its center. So here our center is the point P, so we have circle P. Now some stuff that we already know. A diameter is a segment that contains the center of the circle and has both endpoints on the circle. So our diameter here is segment AB. Now the diameter goes through the center. That's how you know it's a diameter, because it passes through the center. We can mark center here in purple. A radius is a segment that has one endpoint at the center and the other endpoint is on the circle. So the radius has an endpoint, just a segment PC. That's our radius. The radius, I guess you could say, starts at the center and has a point on the circle. Congruent circles, what does congruent mean? Exactly the same. Congruent circles have congruent radii. That is an extremely important idea there. If you have the same radius, you're the same circle. Now, circles don't have any sides. We've been basing all of our information, all of our properties and everything on sides and angles. Circles don't have any sides. Circles have a radius. And that's how we identify circles, is by their radius. So congruent circles have congruent radii. And then here is a friend that we met a couple sections ago. The central angle is an angle whose vertex is the center of the circle. So we can mark this angle right here. That's a central angle, and it's just made by two radii. The central angle is between two radii. So we could add that in, between two radii. Something to remember. All right, some more vocabulary that you probably already know. This first part here, important one, arc, and arc is just part of a circle. It is, you go around the circumference some distance, and that is an arc. One type of arc is a semicircle. A semicircle is half of the circle. Now you know a semicircle. A minor arc, minor means less than, is smaller than a semicircle. So notice here, this says arc RS. Notice our notation here. This is a minor arc. Arc RS, notice our little arc symbol up here. Not a segment, it's curvy, it's an arc. Arc RS is a minor arc. We also could have named that arc SR, just from endpoint to endpoint. Now you'll notice that this is very similar to segments in our polygons. This is just the circle notation. A major arc, you guessed it, is larger than a semicircle. So arc STR, so we started here, S, went through T and around to R, is a major arc. We also could have named this arc RTS. We could have started at R, gone through T, and hit S. We'll make a little note over here. This could be arc SR. You name, we need a matching color here. You name a minor arc by its endpoints, and you name, we'll underline name in red, a major arc or a semicircle by endpoints and another point on the arc. So that's where point T comes in here. Our major arc here, the endpoints are R and S, and you pass through T. That's how you know it's a major arc. Major arcs get 3 letters, major arcs and semicircles get 3 letters, minor arcs get 2. So let's take a look at our first example. The minor arcs of circle O. There are many of them. We've got little arc AD, arc CE, arc AC, arc DE, lots of little minor arcs. Anything less than a semicircle. And what are the semicircles of circle O? Well, there's a couple of these as well. Notice that there's a diameter. So we have, oh, I did the wrong diameter first. There's our diameter. So A through C to E. And our other diameter, C through E to D. And we can also go through E to D to A, or from D through A to C. So we've got 4 of them there. The major arcs, all we have to do is go from one point past. So let's do A, go all the way around through C, and all the way around to D. That's a major arc. This one could also have been named arc AED. That would have been the same as ACD. And then there's more of those. You can read through them. It's just who is a major arc? Who goes bigger than a semicircle? You name it with one of the points that you pass through. So let's try to put this here. This could also be AED. All right. So you see how it's done? Go ahead and pause the video and name some arcs. That was a pretty easy problem. There was a lot going on in there. So our minor arcs, I just started at R and did all the little pieces. RS, SP, PQ, QR, anything less than a semicircle. And then our semicircles, I found my diameter. I know it's a diameter because it passes through the center. And so that's RSP and PQR are the semicircles. And then major arcs, well, there's a ton of those. I just started at R again and went past my semicircle. RSQ could also have been named RPQ, right? And then SPR, PQS could have also been named PRS. QR RS, QR, all the way around to P. That's a really big major arc. Could have been named QSP. Okay, so we've got circles and diameters and radii and arcs. That belongs over here. What are we going to do with this? We are going to do arc measure. Okay, what is the measure of the arc? The measure of a minor arc is equal to the measure of its corresponding central angle. So if we look at our minor arc here, the measure, look how we write this, it's kind of like an angle, the measure of arc, RT, so we're looking at this length, or I mean this part of the circle, the measure is the same as the measure of angle RST, because S is the center of our circle here, is 50 degrees. The central angle is 50 degrees. This arc measures 50 degrees. The measure of a major arc is the measure of the related minor arc minus 360. Or 360 minus the minor arc, sorry. So we are looking at our major arc here, goes around there, arc T, Q, R is 360 minus 50. So this is 310 degrees around our circle. So this arc measures 310 degrees. And the measure of a semicircle, you guessed it, 180 degrees. It forms a straight angle. All right. Adjacent arcs are in the same circle and have exactly one point in common. Now that makes sense, doesn't it? It's just like adjacent segments, adjacent angles. Adjacent arcs have one point in common. Well, what are we going to do with that? Look, it's one of our old friends. We have another addition postulate. The arc addition postulate says the measure of the arc formed by two adjacent arcs is the sum of their measures. So the measure of arc ABC is the measure of arc AB plus the measure of arc BC gives us the measure of the entire arc. This is another piece plus piece equals whole. Let's look at a problem for that. We want to know the measure of each arc in circle O. Well, I have a diagram. First thing I'm going to do, yes, label everything. Okay, well, I know if this angle here is 32 degrees, I know this arc measures 32 degrees. If I know this arc measures 58 degrees, this angle measures 58 degrees. And right here is my diameter, which I know measures 180 degrees. So I can do 180 minus 58. And this angle right here is 122 degrees, which means this arc is 122 degrees. And then this side over here, 180 minus 32. So this angle right here is 148 degrees, so this arc measures 148 degrees. So now all I have to do, arc BC, well, arc BC measures 32 degrees. Arc BD, how do we get BD? From here to here is arc BD, so that's 32 plus 58. It's going to give us 90 degrees. and so on and so on for the rest of them. Arc ABC is our semicircle, so it's 180, and arc AB is 148. And you know what that means. It's your turn to pause the video and do the next problem. This was pretty easy. We labeled all of the angles in our circle, and then we know that all of the arcs have the same measurement, and then we are just asked the measure of various arcs. So PR there, arc PR is just 77 degrees. Now arc RS, well, I marked my diameter. That's the first thing I did. And then that's 180 minus 77, so that's 103 degrees. And then arc PRQ goes all the way around. It's a major arc, it has 3 letters. And so 77 plus 105 plus 28, or I know this is 180, so 180 plus 28, 208. And arc PQR, so I start at P here and go this direction all the way around to R. So I can add up all of those, 152 plus 28 plus my 103, that's 3, plus my 103, or I can just do 180 plus 103, it's 283. All right, so arc measure means we use degrees. So arc measure, the arc measures the same as your central angle. So nothing too difficult about that. Labeling your diagrams is really the way to go.